Let's talk about latency. Latency Latency is an issue in all audio systems. It is the delay incurred by the transport and processing of audio signals. This is really only a problem in settings where the delayed and undelayed signals are heard simultaneously, as in a recording studio when doing overdubs on a digital recording system, or floor wedges on stage that are combined with the sound of live instruments. Of course, audio latency is very pronounced without any electronics at all. Since sound travels at about 343 meters per second, each 34 centimeter of travel requires about 1 millisecond. If you'd like to hear what a system sounds like with about 2 millisecond delay between sources, then just stand in the middle of two stereo speakers and move 34 centimeters to the left or right. This air travel latency is why delay towers are used to align speaker output with the audio coming from the stage in large outdoor concerts. The travel time results in a very large latency problem that needs to be overcome. In earlier audio networking solutions, such as Voice over IP, high latency was a real issue. As we'll see, this is an area where Dante gives you complete control. To access controls and monitoring for Dante latency for any device, double-click the device name to open the device view window. Then, set latency for device in the device config tab. View latency monitoring for channels being received by device in the latency tab. In Dante, latency is strictly defined and consistent. Default device latency is 1 millisecond, far below the threshold of noticeability for live performances or studio overdubs. At this setting, receiving devices can be used on very large networks employing up to 10 switches. This setting is made on a per-device basis and is extremely conservative to ensure trouble-free operation. The advanced filter in Dante controller may be used to see devices filtered by latency setting. This can be useful for quickly checking to see that all devices are set for consistent playout. You can set Dante devices to go as low as 150 microseconds or as high as 5 milliseconds to suit different situations. The factors that affect how these settings can be used are dominated by the network structure. Remember the Dante latency rule. Latency of a connection is always the higher latency of the two devices. Dante latency is deterministic, that is, we set a value on each device and they all use that value in order to play out samples in exact sync. But this fixed latency has some lower bounds to which we must pay attention. As an example, a very small Dante network with only one switch may use the lowest Dante setting of 150 microseconds. As the number of switches and thus devices grow, our minimum value increases. For networks with 3 switches, minimum latency is typically 250 microseconds. At 10 switch hops, the recommended Dante latency is 1 millisecond, which is a common default value. Keep in mind that 10 switches is quite a lot. If each switch has only 10 ports, that is 100 devices supported. And 1 millisecond is very small, only 34 centimeters of air travel time. It's important to note that the recommended latency values, while already very small, reflect worst-case scenarios. In many cases, you may safely use lower latency settings than the recommended values in Dante controller. The latency monitor in Dante controller shows you the real status of latency and is the best indicator that you have configured to work well on your real-life network. In this example, we are using 3 switches and a latency setting of 1 millisecond, the default for most Dante devices. We can see that the packets are arriving at different times, but that all of them are well below the latency setting of 1 millisecond. This is a healthy state of affairs. All of our packets are arriving within our window of safety. You can safely experiment with lower values if you wish, as long as packets are arriving well within the defined window of time. The Dante network will work fine. In this example, we have reduced the latency setting to 250 microseconds, a very low value. When we look at the latency monitor, we can see that some packets are now falling dangerously close to the limit of our latency setting. We have selected a value that is too small for the physical network we are using and should change settings to avoid problems. Latency monitoring can also be used to diagnose network problems, even those that are infrequent. Monitoring may be left on for hours or even days to capture the occasional dropout. The exact time that packets arrive will vary depending on traffic, and so it is normal for packet arrival times to vary some. If packets are falling outside the latency range desired, then there are a few possible causes. Too many switch hops increase latency to accommodate size of network. Too much traffic increase latency and or implement quality of service. Marginal equipment, a switch or a cable may be misbehaving and need replacement.